All right, I'm going to work through just a couple example problems from this pink review packet. Notice in the directions it says leave no negative exponents. If you remember, our negative exponents turn to positive exponents when they get moved to the bottom of a fraction. And then this is something I would believe you could do. 3 squared is the same as 9. So if there's a negative exponent, in order to make it positive, it goes to the bottom. Remember, anything to the power of 0 is always equal to 1. Okay? Now, this is a trick though. This would have to be negative 15 to the 0 power in order to equal 1. This is actually saying negative 1 times 15 to the 0 power. So negative 1 times 1 is actually negative 1. This would be an example of positive 1, because this whole thing is to the power of 0. How do you make a negative exponent positive when it's on the bottom of the fraction? Now it moves to the top. Negative exponent positive moves to the top. Okay? All right, what do we do when we have numbers and variables? Simplify the numbers first. Negative 12/8 reduces to negative 3 seconds. I would bring this x to the negative 3 to the top to become a positive 3, and I would bring this y to the negative second to the bottom to become a positive. And then I would work on 5x's and 8x, 3x's give me 8x's, 1y and 2y's give me a y to the third. So you had to do some moving of your positive and negatives and then combine. Remember, if there's an exponent outside, you distribute to everything inside. So this becomes negative 3 to the second power, x to the second power, y to the fourth to the second power. Negative times negative 3 is a positive 9, x squared, y to the, and we have a power to a power, we multiply. 4 times 2 is 8. So same thing with number 17. This negative 3 goes to every single term. So this becomes 2 to the negative 3, y squared to the negative 3, over 4 to the negative 3. Well, how do I make this 2 to the negative 3 become positive? It moves to the bottom. 4 to the negative 3 becomes positive on the top. Multiply these together. This is like y to the negative 6, and it becomes positive on the bottom. Now, technically, you probably could figure this one out. 4 to the third power just means 4 times 4 times 4, which is 64. 2 to the third power is 8, and this could reduce to 8 over y to the 6th power. So that's another option. What do we do when we have the same bases? Well, this would be 10 to the 4 plus negative 7, which is negative 3. But how do I make that a positive 3? I move it to the bottom. So if you look at 22, this is 10 to the 3 plus 4 or 7 over 10 to the 2 plus 1 or 3. I have 7 tens on the top, 3 tens on the bottom, or a difference of 4 tens total on the top. So there are a lot more problems that you can practice through, but those should give you some ideas. Factors and zeros. This is just the same thing as solving this equation for a 0. And what do we know when we have two terms being multiplied together that equal a 0? One of these has to be a 0. So we have the zero product property. Something times something equals 0. What makes it a 0? Well, either 2x minus 1 has to equal 0, or x minus 5 has to equal 0. If I add 5 to both sides, x would equal positive 5. When I add 1 to both sides and divide both sides by 2, x equals 1/2. So same thing here. What makes this equal to 0? Well, I have something times something times something. So now 3 things equal 0 when being multiplied together. So either this equals 0, this one equals 0, or the last one equals 0. And so we have 3 equations to solve. When I add 3 to both sides, x equals 3. When I subtract 1 from both sides and divide both sides by 3, I get negative 1/3. And when I subtract 1 from both sides, x equals negative 1. Same thing here. Something times something times something. Either x equals 0, 5x minus 2 equals 0, or x squared plus 1 equals 0. This one's done. If I add 2 to both sides and divide both sides by 5, I get 2/5. If I subtract 1 and try to take the square root of a negative, you get an error. So this one has no solution to it. So those are just some different ways to work with finding the zeros using the zero product property. And product just means multiplication. Okay? Find all the zeros. That just means find the solutions. Remember, one side has to equal 0. We look for a GCF, and then we factor by either reverse FOILing, looking for the difference of squares. So here, if I make one side equal to 0, that is done. Now I need to look for a GCF between all 3 terms, and that GCF is an x. So I'm going to factor out an x, and when I factor out an x, I'm left with this, because x times x squared is x to the 3rd, x times negative 2x is negative 2x squared, and x times 1 is 1x. And now what two numbers multiply together to give me a 1, but add up to give me a negative 2? And that would be negative 1 times negative 1. So now I'm going to factor this part into x minus 1, x minus 1. But don't forget about this x right here. And now when I go to solve, I've got the zero product property again. Something times something times something equals 0. So either x equals 0 or x minus 1 equals 0. These are the same, so x equals 1 or x equals 1. Let's not do this one here. Actually, I think that's just a good example of how to solve quadratic equations. How do we multiply polynomials? Some of you like to double distribute. Some of you like to set up the box method. So this would be 2p to the 3rd, positive 5p squared, and a negative 4. This would be 3p and a positive 1. And now we multiply within our boxes. When I multiply these two terms together, I get 6p to the 4th. When I multiply these together, I get 15p to the 3rd. And when I multiply these together, I get negative 12p. Multiply these together, 2p to the 3rd, 5p squared, and a negative 4. And now combine like terms. There are no other p to the 4th. I do have 2p to the 3rd and 15p to the 3rd, which is 17p to the 3rd. I only have a positive 5p squared, a negative 12p, and a negative 4. So again, you can set up the box method for all of these to make them work. When we add, it's different. We look for like terms. So I have a negative 2x to the 4th and a positive 5x to the 4th, which is a positive 3x to the 4th. Then I have a negative 4x to the 3rd and a positive 5x to the third, which gives me a positive 1x to the third. So my answer here would be D. Now, when I multiply, remember this is like having a negative 1 in front. So you have to distribute. So the 5r squared minus 1 stays the same. But now negative 1 times 8r squared is negative 8r squared. And negative 1 times a positive 4 is a negative 4. And now we combine like terms. 5r squared and a negative r squared is a negative 3r squared. A negative 1 and a negative 4 is a negative 5, so letter B. Okay, I will do that again so that you can see the subtraction. The first part stays the same, but the second part is like having a negative 1 there. So negative 1 times negative 6 is a positive 6. Negative 1 times negative 2x is a positive 2x. And negative 1 times x squared is a negative x squared. Now I combine my like terms. Negative 7x squared and a negative 1x squared is a negative 8x squared. A positive 2x and another positive 2x is a positive 4x. And then we have our positive 6. So letter D. Number 10, we have some adding and some subtracting. So this stays the same. This stays the same. And now that it's going to be subtraction, now we distribute the negative 1. So negative 1 times 1 is negative 1. And negative times a negative is a positive 7b to the third. And now we look for our like terms. We have negative 8b to the third and positive 7b to the third, which is negative 1b to the third. This is our only b, so it's a negative 4b. And then we have an 8, a 7, and a negative 1, which gives us a positive 14. So our answer is B. So when you add and subtract, you're combining like terms. When we multiply, that's when we have to deal with numbers and variables. So if I distribute here, negative 5 times 10 is negative 50. X to the 5th times x squared is x to the 5 plus 2, or 7. Negative 5 times positive 5 is a negative 25. X to the 5th times nothing else is just x to the 5th. So my answer is B. This is another example of, if you want to, you can use the box method and set this up. Or you can double distribute, whichever way you want to. I still think the box method helps you not get any mistakes. So this would be 54y to the third, negative 9y squared, and a negative 36y. A negative 6y squared, a positive 1y, and a positive 4. Combine your like terms, and this would be your final answer. And that looks like that matches up with letter B. When it's a 2 by 2, again, you can do the box method, or some of you like to FOIL. I'm going to FOIL since I haven't done that. First, we get 2x squared. Outer, we get a positive 22x. Inner, we get a negative 6x. And last, we get a negative 66. Remember to combine your outer and your inner, and that gives us letter